Hello class, welcome once again to our discussion for today. I will continue our discussion on the derivative of inverse hyperbolic functions. So this time we are going to solve example number 3. So the given is find the derivative of the function y equal to inverse hyperbolic tangent of the square root of x, or we can read this as y equal to the arc hyperbolic tangent of square root of x. Okay, so for solution, first let us just rewrite the given. Y equal to arc hyperbolic tangent of the square root of x. Okay, so find the derivative. So we have to take the derivative on both sides. So derivative of y with respect to x equal to the derivative of arc tangent or arc hyperbolic tangent of the square root of x, or inverse hyperbolic tangent of x, square root of x. So derivative of this with respect to x. Okay, or we can express this square root of x in terms of its rational, x with its rational exponent. So we can rewrite this as the derivative of y with respect to x equal to the derivative with respect to x of the inverse hyperbolic tangent of x to the power 1/2. Okay, and then we're going to use the formula for arctangent of the derivative of the arctangent of x. So we have from the formula the derivative of the arctangent or inverse hyperbolic inverse tangent of x with respect to x, which is equal to 1 divided by 1 minus x squared. Okay, or in general form we can also say that the derivative of the inverse hyperbolic tangent of u with respect to x is equal to 1 over 1 minus u squared times the derivative of u with respect to x. So I'll apply a chain rule here, or in another notation we can also say that the derivative of the inverse hyperbolic tangent of u with respect to x, this is equal to 1 divided by 1 minus u squared times the derivative of u with respect to x. Okay, so these are the formulas that we're going to use. So any of this class you can just remember or recall, no? If you memorize this, and then you can recall this formula when you're dealing with inverse hyperbolic tangent function. Okay, so in our given, so this is our u. Oh, this part here is our u. Alright, so using the formula, using this formula here, so we have the derivative of y with respect to x is equal to, we have 1 divided by 1 minus our u here is x to the power 1/2. Okay, and this part here, u, so from formula this will be u squared. Okay, so we have to square this part, then times the derivative of u, so we'll apply the chain rule here now. So the derivative of u, our u is x to the power 1/2, so the derivative of this with respect to x so we will use the power rule here. So what is the power rule? So if you have derivative of u to the n with respect to x, so the general power rules, we have n times u to the n minus 1 times the derivative of u with respect to x. Okay, so equal to, so just copy this one, we have 1 divided by 1 minus, so x squared squared, so this will be x, so we apply the log exponent x to the m. From the log exponent we have x to the m raised to another, or x exponent, x to the exponent m raised to another exponent n, so this will be x to the m times n. Alright, so our exponent here m is 1/2, then you have n, another exponent n which is 2, so 1/2 times 2, that is equal to 1, so x to the power 1, or simply x. Okay, so derivative of this using the power rule, so the power, the constant here, the exponent will go down, so this is 1/2 times x to the power, so from the formula n minus 1, our n is 1/2, so 1/2 minus 1, so this will be negative 1/2. Then our u here is x, so times the derivative of u, where u is x, and with respect to x, so dx over dx that is equal to 1. So this is equal to, so we can bring this down, and you can write 1/2 first. Okay, they say since this is multiplication class, so we can have or before that one we can rewrite this as 1 divided by, or you can write this constant here, that is 1/2, so 1/2 times, okay, we can bring this down, that would be 1 over x to the power 1/2, then you have here 1 minus x, or this is equal to, so the rule in multiplication of fractions, you just multiply the numerators and multiply the denominators, so therefore we have 1 times 1 times 1 is 1, then 2 times 1, the quantity 1 minus x, times x to the power 1/2, or you can write this as square root of x, so therefore our final answer is 1 divided by 2 times square root of x, and times 1 minus x. So this is our dy over dx. This is our final answer. Okay, so I hope you have understood this solution, class. Alright, so we'll see you again in our next example number 4. Thank you very much. Bye.